Hi everyone, I'm Derek Novavi. I'm one of the editors of the FDC3 Standard. I work as a front-end architect at S&P Global Market Intelligence, and I'm here with Kris West, who's the lead maintainer of the FDC3 Standard, and he works at the Open Source Program Office at NatWest Group. We're here today to talk about a new proposal called FDC3 Subagents and how this can help us with our app composition. I'm going to touch very briefly on the motivation for this work. So there's a limitation with FDC3 in that it currently only supports one app per window scope rather. Now there's a piece of work that kicked off 2 years ago which was aimed at making FDC3 work better in web browsers. As part of this work, there was interest expressed by several participants in FDC3 supporting multiple apps per window scope. The group ultimately decided to defer this work until FDC3 2.3. At this point, I'm going to hand over to Kris, who's going to provide a really useful background into FDC3 and how we got here today. I'm then going to return and talk about the subagents proposal in more detail. Over to you, Kris.
Thanks, Derek. And as Derek said, he's asked me here today to provide a bit of background for the proposal to help people get involved with it and move it forward in our next version of FDC3. And I'm very grateful to Yannick for not making this the third introduction to FDC3 that we'll do today. But essentially, like going right back to the beginning, FDC3's charter is to enable applications in financial services workflows to interoperate in a plug-and-play fashion without prior bilateral agreements between apps. It's a fairly complicated bit of language there, but it's essentially saying that by working through an open standard, we aim to help apps to interoperate and build an ecosystem of those that are able to do so, achieving that with low integration costs, so not everything has to work on plugging into everything else, rather it plugs into the standard, and that enables us to build fast and error-free workflows for our users. Now, we do that through something we call the Desktop Agent API. The original, the earliest ones, and probably the most common still, are based on Electron-style containers hosting web windows and other technologies, potentially. It offers a simple interop API supporting what they used to call the lowest common denominator of interop operations. I think I heard you say this a few times in the early days, Johan. It's been an important concept for FDC3 though, because it's made it accessible, it's made it easy to adopt. Now, those operations that it undertakes are things like launching apps with a bit of context so they know what they're supposed to show when they come up, raising intents, which could be resolved on a newly spawned app or an existing app. It's delivered over there, not just with the context, but also, I want you to do this with it. And lastly, communication channels, which work in a variety of different ways, but are to allow us to share context between the applications so they can follow around with what the user's doing. Now, we couple that with a set of standard intents and context objects describing the things we want to talk about, and we enable easy cross-firm and cross-vendor integrations, even, I don't say it here, but cross-technology integrations where an implementation supports it. Now, that has gone pretty well. We had, even in the very early days of FDC3, pretty strong initial adoption of FDC3-enabled desktops by sell-side institutions. They were typically building themselves, but they were supported in doing that by multiple vendors of desktop agents. I know there's at least 2 here today. There are a variety of fintech firms publishing individual applications, so one block in the wall on the screen. Market data providers that might have many of those blocks, and service providers, consulting firms, etc., who worked with people to assemble all of this into desktops. There's been recent, and by recent I mean the last 2 or 3 years, uptake by buy-side firms and even efforts at buy-side and sell-side integration. We've just seen a bunch of that that Yannick and Matt have been talking about. So that brings us to the question of whether it's solving the problems. And we can sort of assess that by looking at some of the FDC3 use cases. There are a whole bunch of them. I'm going to approach these from a particular angle though. The first and most obvious for those sell-side institutions was assembling in-house desktop experiences. As I said, we're making headway with buy-sides, other financial services firms as well that don't necessarily fit on either side of the street. But lots of people are building desktops. They're typically focused on in-house apps and a small number of keystone vendor applications that are stitched into that. Often those come with some sort of on-premises deployment, although SaaS applications in FDC3 workflows are becoming more common. Now, the configuration of that desktop is generally provided by and controlled by the adopting firm, the firm that's rolling that out on their desktop. And that's working pretty well. The second use case is often componentizing and modernizing legacy platforms. Most of our organizations have been building software for a very long time. They've probably even gone through previous rounds of making it all interoperable with each other with different technologies. But there's often a need to modernize it. It's big. It may cross many silos, many different teams. It makes life a lot easier if you can componentize it with FDC3 and then modernize it in stages, replacing one piece at a time. It makes cross-silo and cross-tech interoperability a lot easier. I'm crossing out integration there because these things are not plugging directly one into another. They're plugging into the FDC3 standard and thereby interoperating with each other. It also enables individual delivery and release schedules for all of those teams. The old monolithic desktop applications, many people in the early days were reporting to us we had 6 months or year-long release cycles just trying to get the next version out. Now they can move to a rolling basis for each of the applications. So that as well is working very, very well. So a third one though, which is one I focus on with this particular topic. I know there are other use cases, some of which Derek's going to go into. But one of the ones I've been most interested in over the last few years is firms looking to publish whole suites of applications. They might be, it's just a couple of examples here, something like a market data terminal replacement that's been put together, or a set of buy-side and sell-side integrations, or indeed any fintech that's got multiple applications, multiple different pieces that they want to put out on the desktop together. Now, there comes a point, though, when they want to put these multiple pieces into somebody else's desktop, that they think about whether they want to put all of them in there, whether they want to get them to integrate each component, or even whether that client wants to integrate each component. Sometimes they want to push the whole unit, and this would be a very common thing as any technology vendor. You want people to use more of your tools, so you'll typically put them out together as a platform. Now, the integration is more complicated, and it's often leading to firms wanting to or needing to push out a whole desktop agent alongside the applications. That has some really good advantages. The vendor manages the config. If I decide I've got a B4 I want to deliver and I want to retire B1 as the vendor, I can just do that. I don't have to go to all of my clients and say, could you pull out B1 and put B4 in? You've just delivered the desktop agent and you're in control of that. However, it leads to, pretty instantly, some islands of interop. These things are interoperable with each other, but not across the divide between the desktop agents. So we needed some solutions for integrating whole platforms, and we have done a fair bit of work on that topic, as I think Juliana mentioned earlier. In FDC3 2.1, we developed something we call the bridging protocol, which is there to allow the desktop agents to talk to each other and to interop, so that the interop for their apps can just pass across without them having to know about the other agent. So again, it was intended to make it simple for the app developers and for the publishers that are pushing out whole desktop agents to make these things work together. It's not there yet, largely because we lack a complete open source implementation of a bridge out there. Makes it difficult for somebody developing a desktop agent to pick one up and build against it. As I said, I think earlier, we've got some really good technology base for one, but not yet a complete implementation. And that has led to, I believe, a lack of support in most desktop agents from vendors in being able to use it. However, pretty much all of them that I'm aware of offer some form of bridging-like solution that allows different platforms, different groups of applications to be published separately to talk to each other. There are various product offerings in that space. So I think that supports the use case for doing it like this. We then, the following year, right up until April of this year, been working on FDC3 for web browsers, which Juliana has ably introduced for us already. Essentially make the thing work in a web browser. We're stuck with incorporating a library. In order to do that, a library has to go into the applications using proprietary libraries from particular desktop agents, limited our ability to build an ecosystem around that, as everyone has to target a specific agent or all of the agents, neither of which is an ideal situation. So we did the work necessary to make it possible to import the FINOS FDC3 library to just work with any desktop agent, whether it's a container, whether it's in the browser, whatever implementation it is. It's backed by a protocol, so if somebody else implements that library, I know there's at least one person doing so, they can also be fully interoperable with everything else. So that's brilliant. It supports interoperability between apps running in whole browser windows or running in multiple iframes within a single browser window. These can all be working with the same desktop agent. Okay, so they will naturally share context with each other. However, we do still have the platform level integration issues that I introduced. Say, for example, we've got our web-based desktop agent that's running alongside a container-based desktop agent on the same machine. We are in the same place. We've got a couple of islands of interop. They're able to talk to each within their own scopes, but not with each other. And that applies whether we've got a container-based desktop agent and a browser-based one, or two browser-based agents, you're still stuck. So there is an alternative to bridging that came up in conversation during the FDC3 at the web meetings, which is to do with the fact that we are, it's not usable at the moment because we are forcing a particular way of doing things in FDC3 for the web. So we are forcing the integration of multiple apps within one browser window to be a set of iframes. Rather than enabling some easy integration by other techniques, there are a variety of modern bundling techniques that can bring multiple web applications into a single window context to run, and Derek will tell you a bit more about that in a bit. But our biggest problem right now is FDC3 for the web offers a single API endpoint per window. So our apps on the left can all talk to each other, and they can talk to the window with the apps on the right. The apps on the right can't actually talk to each other using FDC3. We don't deliver messages back to ourselves, so as we've only got one API instance, we can't talk to the other parts of the same window. And ultimately, that presents challenges for people with existing web platforms, which you'll go into in a bit more detail in a moment. This was identified while we were doing FDC3 for the web, but the group ultimately decided that as we were going to need to work at the window level to connect to a window-based desktop agent, we'd start there and we'd defer solving this further problem to FDC3 2.3. So with that, I will hand you back to Derek, who has done a lot of thinking on this topic, and I think he's going to tell us what it's going to take to solve some of those additional use cases and some of the decisions we've got to make. Thank you.
Thanks, Chris. Right, I'm going to just start off here by reviewing what FDC3 currently does well. We know it provides a good mechanism to provide standardization of communication between our apps. It's also really good when we're developing entirely new platforms from scratch. And it allows us to take self-contained apps components and put them into those new platforms. It excels at providing interop between in-house applications and third-party vendor applications. It does this by providing strong application isolation by running these applications in separate windows. And it ensures that the communication is via messaging, not via code execution. But there's some things, as Chris said, that FDC3 does not yet do so well. One is the evolving existing web platforms. This is an important point because a lot of large organizations have significant investment in existing platforms, and it's typically a multi-year and expensive effort to get out of those platforms. And in particular, again, as Kris said, we can't yet run multiple apps in the same window or in the same document object model and use FDC3 to communicate between those apps in that window. And the reason FDC3 can't do these things so well is, as we've just seen, FDC3's origins lie in desktop containers, and these platforms were designed to compose separate windows into layouts or dashboards. Web apps essentially have to be hosted in separate windows or iframes, and fundamentally there's a one-to-one relationship between window URLs and FDC3 app IDs. And again, apps can't listen for messages that are broadcast within the same window. So just stepping back slightly and looking at app composition more broadly, aside from FDC3, oftentimes we run multiple apps in the same document object model. And there's lots of reasons why we do this. It results in fewer browser processes. There can be a lower memory overhead because we can share dependencies between those multiple child apps in the same window rather than loading those dependencies multiple times. There's also fewer UX constraints. If you think about, for example, a child app that wanted to surface, say, a pseudo-modal window, if the child app is running in an iframe, it's limited by the viewport of that iframe. It can't use the whole real estate of the parent window. And there's a number of techniques that people use to support this sort of composition. We might use lazy loading at the framework level. We might use module federation as provided by our tool chain, for example, if we're using Webpack. And we could also use things like web standards, vanilla ES modules with dynamic import expressions and import maps to do similar things. So the question that follows from this is, why should we have to restructure our platforms to use iframes just in order to start using FDC3? So we want to make it easier to add support to FDC3 to existing platforms. We want FDC3 to be able to support modern app composition techniques. We want to be able to retrofit FDC3 support to our existing platforms, so we don't always have to put them into new platforms. And we do this by lifting the requirement to host apps in separate windows or iframes. And this is where the new FDC3 sub-agents proposal comes in. It will work as follows. Child apps will get their own copy of the FDC3 API interface with their own child app identity on it, not the parent app identity. They'll do this by using the new proposed get sub-agent method. And I need to be clear, this is an additive change to the FDC3 standard. It will not alter our existing apps or platforms. They can continue to use FDC3 in the same way they do today. What this does do is it solves additional use cases. It will allow multiple FDC3 enabled apps to run within the same parent window or within the same document object model for the first time. Importantly, this is agnostic of how your platforms or your apps are constructed. It doesn't matter whether the child apps, for example, are eager loaded or lazy loaded or whatever technique you've used to bring them into the world. The important thing really is that those apps are hosted in the parent app window and they execute in the parent app window as opposed to within iframes. So in working through this proposal, it's clear that there's a number of different open questions, the first of which relates to relationship and scope. So child apps need their own identity for handshaking purposes when they first instantiate a FDC3 sub-agent. There's also the question of whereabouts in the workflow the child app sub-agent should be instantiated. There's also a question about the parent app to child app relationship. For example, should a child app only be able to exist under one specific parent app, or should it be possible for that child app to also be run under a different child app? Related to this, there's a question of whether the child app record should exist in the FDC3 app directory in the same manner that regular app records do today. Other questions relate to the launching of child apps. Just stepping back slightly, if you think about regular apps today, when you have an FDC3 desktop agent that needs to spawn or launch a regular app, it can simply look up the URL for that app from the FDC3 app directory, and it can use that URL on a window URL or an iframe source, and that's all it needs to do. But when you think about child apps running directly in a parent window, there's no single standard for loading and bootstrapping of those apps. It's platform specific. And this isn't something that FDC3 can solve. So the question that then arises is it even feasible for FDC3 to support the launching of child apps at all? On the one hand, if we don't support this, we then have to think about what happens to ambiguous intents and things like FDC3 to open. Does this lead to two different classes of application? And what does that mean and how do we manage that? On the other hand, if we do provide a solution for this, there's then questions about how we actually do that, given the lack of standardization here. So we could think, could dynamic registration help? Do we need to support some element of callback functions at platform level? Clearly there's quite a lot of complexity that needs to be worked through there to come to an agreed solution. Other questions relate to application lifecycle. If you think about how this will work with child apps, the desktop agent would need to track currently running child apps in the same manner as it does regular apps today. That part's probably quite uncontroversial. But when you think about teardown of apps, again, looking at regular apps, if you've got a regular app in a floating window and you close that window, or maybe you've got the regular app in an iframe and you remove that iframe from the document object model of the parent window, we benefit from things like the page hide event, so we can get notified of that. And if you're using message ports, there's similar things you can do there as well. But again, when it comes to child apps, there's no single standard for teardown. Again, it's framework specific, it's platform specific. So when a child app is destroyed, the question is, how should it dispose of its subagents? And how can we provide a robust way of doing this within the FDC3 standard that allows us to be comfortable to put this sort of thing into production? So looking at some of those questions, it's clear that there's sort of a spectrum of different solutions, ranging from the sort of minimum viable solution at one end to an advanced, fully featured solution at the other end. Clearly, any solution has to support multiple child apps in the same window, and it has to allow interop between those child apps. That's the entire purpose of the exercise after all. But there's certain things, for example, launching of child app instances that I just talked about, where actually we could get a lot of value out of a solution even if it didn't provide that in the first version of that solution. But again, a more advanced solution might provide that. There's a number of other things as well. I've only picked out a few, but another example of something that a more advanced solution might provide would be to make it easier to run our apps in two different modes, either in parent mode, so that you benefit from that strong isolation and you're comfortable using it for interop with third-party apps, but also potentially in child mode, where you want to embed it inside your own platform and you don't have the same need for that level of isolation. So just to visualize this in terms of some message flows, for example, if you've got a main window running an FDC3 desktop agent, right now today with FDC3, we can support apps running in floating windows, and we can use FDC3 interop with those. And then we can do the same when we have apps running in iframes in a workspace window. They might even be within a layout manager in there. And so that part we retain, but what we do is we add to that with this new sub-agent proposal, and we also support this type of interop, where we've got apps running directly in the parent window. The key point is that they are hosted and executed in that parent window. They're not running in iframes. Finally, just to try to wrap this up with a little code example, I should prefix this by just saying this is not a final proposal, and this is subject to change. But we've got an originating child app and a target child app example here. So how this would work with subagents is, first of all, a child app would acquire a reference to their parent app's desktop agent. Then they'd use that desktop agent and they'd invoke the new getSubagent method and get a reference to a subagent that's specific to them and uses their identity. Thereafter, the child apps can then use that subagent and use the existing FDC3 methods that we're already comfortable with using to communicate with one another. The key point is that the child apps are using the subagent here for the comms with the other child apps. They're not using the parent app desktop agents. This is important because whether you're an originating app or a target app, you need to be using your own child app identity there and not the identity of the parent. So in this example on the left, we're simply raising an intent to the other child app, the target app. On the right, we're listening for that intent. So just to summarise what we've talked about, we've seen that the current FDC3 standard only supports a single desktop agent API instance per window. We've seen that it does not allow multiple apps or components to talk to each other using the FDC3 standard. And we've seen that it's problematic to use FDC3 when we're trying to use modern app composition techniques, specifically on existing platforms. The new FDC3 sub-agent proposal is designed to solve these problems. Child apps will use the proposed new get sub-agent method to acquire reference to a sub-agent. And overall, this has the potential to simplify the retrofitting of FDC3 support to existing platforms. I also just want to call out the fact that there's an opportunity to get involved, so please do share your use cases, those of you that haven't already, and potentially get involved and help finalise solutions to these problems and other problems, either in the Standard Working Group or in the related discussion groups. I also just wanted to plug the fact that there's another couple of FDC3 related talks happening later this afternoon, and if you didn't catch the talks from Juliana, Yannick and Matt this morning, I definitely recommend you try and get those on replay when the video is released in the next week or so. With that, I'm done, and I'd like to turn it over to Q&A. Thank you.
Hey, Derek.
Hi.
Yeah, thanks a lot for all the hard work you and Kris are doing on this. It's very appreciated. I mean, I think what we're starting to see is we have a desktop platform, and we use FDC3 to communicate between different applications run by different application teams. What we're starting to see now is certain teams want to actually have browser-based applications. This is typically, if you're looking for public-facing or something like that, that's where it comes in, and obviously we will use the same FDC3 so it's great to see what you're doing. However, what I imagine we will end up with is containers in browsers and desktop containers, or platforms, wanting to leverage the same concept. So in that case, if we've got this concept of sub-agent, how does an application know if it needs to call sub-agent or if it is the root application, if you like?
Yeah, I mean, it's a great question. I mean, to be fair, some of these things are still being worked through, but there's things you can do to maybe detect your platform at runtime. So if you've got something, if you're looking at purely browser-based, you can see whether you're an iframe or you're a top-level window. I would accept that's a little bit more challenging if you've got something that also runs in a desktop container, because at that point it is a top-level window. So yeah, I'd actually be interested to pick up the discussion further actually with you after, potentially see what ideas you might have on that. But yeah, I mean, it's fair to say this is still ongoing, very much ongoing. We're not sort of presenting a firm specification. We've solved all the problems. At this point, we're kind of figuring out what the questions are, so that we can see, as I say, the spectrum of possible things, what we want to support. It may be that a first version of this has to push some more of the responsibility for figuring that sort of stuff out at platform level. There are things you can do with configs. It just, obviously, if you're trying to do one deployment only and that runs in different places, there is a challenge there. So a bit more work to do, I think, it's fair to say.
Is the sub-agent a complete implementation of the desktop agent in terms of methods it supports?
Yes, but with a caveat. So I mentioned one example being launching of applications, which is significantly harder to solve with a sub-agent, because with regular apps, it's just a window URL, it's an iframe source. With this, you could, in theory, look up a script bundle or a remote entry file from the app directory, but then it's a question of, well, what do I do with it after that when I've imported it? And there's no single way of doing that. So if we wanted to make it complete parity, we probably would need to add in at least an additional method or two, such that within your platform up front you could register handlers that would say this is how you load this particular application or that. But then it gets a little bit complicated, because then it's like, how agnostic of a container are you?
You don't want to launch sub-agents.
Hmm?
I'm almost certain no one's going to want to be able to launch sub-agents.
Well, it's not. It's apps. It's child apps rather than sub-agents. So one example would be a workspace where you've got 4 apps in there. If you want to drag another one into it, at the moment, you need to solve that at the platform level. You wouldn't probably use FDC3 to open. So ambiguous intents would be one which I'd call out, where it isn't exactly the same as a full desktop agent, because you wouldn't, unless we solve that problem, be able to resolve an ambiguous intent and spawn a new child app. So I would suggest the first version of this probably defers that type of thing, because you'd need significant buy-in to try to solve that.
And also you insist on each sub-agent names itself, which is potentially a problem if I'm loading multiple instances of a widget. The widget can't name itself.
Well, yeah, again, interesting. I mean, it would be likely on the parameters when you create it, and you'd have to have the handshaking such that the child app is validated against the URL of the parent app, because of course you don't have a URL for the child app. You might have a script bundle associated, but you don't have its own window URL. So that handshaking piece needs to kind of be a version of what was done for FDC3 with the web. But yeah, I accept, there's caution required in terms of multiple instances and that self-identification piece. I don't know if you want to add to that, Kris.
Yeah, but I mean, the identity side of it is very much not worked out yet. So it's not so much the case that we're insisting the sub-app agents identify themselves. There's a couple of competing ideas there. For example, one I favour is getting the parent platform to do most of those things. To, for example, handle launching. I want the platform to sort this out, and it could decide to add a charting application or using existing sub-application that's got to resolve something. But to go to your original question, the sub-agent that you get should be another copy of the desktop agent API, should be a complete copy of that. And essentially the goal of the whole proposal is to create additional copies of it, so those copies can talk to each other as well as everything else in the desktop. At the moment,
does a multiplexing between the things.
Exactly. At the moment, to do something like this within one window, you have to use FDC3 to talk to all the other windows and build something else to copy all your comms to your other components. And that's the bit I think that a couple of participants, I think they're all here, objected to in having to retrofit a platform. I've got to build FDC3 again alongside using FDC3, which is what they wanted to avoid doing. So it's a great question about why you would do it, and essentially you're just getting more copies so they can talk to each other.
So it would be a full copy of the API, just with that caveat that things like ambiguous intents and open, maybe you'd have to defer on. But the rest of it, so you can, if you want to broadcast on a channel to another app in the same window, you'll actually be able to do now, because you've got 2 different app IDs there, whereas currently today you can't do that in one window.
Awesome.
Any more questions?
Hi, Derek, good to see you.
Hey.
I'd like to, so one of your early slides was moving from C# to HTML5.
Oh, it was Chris's actually, yeah.
Yeah, which reminds me of going back a while with you.
Yeah, years ago now, yeah.
Yeah, it is.
Too long.
I've worked on a project recently that's got Retrofitting FDC3 for external clients, but it's using Blazor for internal.
Oh, really? Okay.
So I just wondered whether that was featuring in your roadmap at all, or obviously it can use
I mean, this presentation was focused really on the website, but it's fair to say that similar challenges do exist within native apps. There's certainly one firm which has expressed that. If you have the same thing, I mean, it would be great to see your perspective on this, and how this type of thing might solve some problems, or what problems you've got that this wouldn't solve. And then if you want to add to that.
Yeah, I'll start by apologising to the whole C# ecosystem for picking on them for replacement. It happened to be 5 or 6 years ago. It was a lot of .NET monoliths that were getting broken up to replace bits with HTML5. But in the discussions on this, exactly the same pattern exists in in those other ecosystems, you've already got monoliths that have got multiple different applications within, and it's actually quite a lot of work to break those up into individual running components, and there's various people who've sidestepped it in various different ways. One firm's used bridging that we talked about to do it. Another firm just pretends to be one big application. We've seen various different examples of it, but you could use exactly the same pattern, and I believe there's at least one person out there thinking about implementing that pattern to make it easier to bust up those monoliths and do the same sort of thing. They would connect to FDC3 and then perhaps on behalf of their sub-applications ask for extra endpoints and hand them out, if that makes sense.
I would just add to that as well, actually, on the subject of kind of breaking up existing monoliths. If you think about existing web-based platforms that maybe there isn't yet an appetite to put into a new platform, or maybe the institution is so large it's got those new platforms elsewhere, but not everyone is using them. By using the sub-agents piece, you can actually start to FDC3 enable different parts of your app, and as a first step towards breaking those out subsequently on their own URLs, on their own routes, that you can then put in Windows or iframes or in desktop containers and interop with third-party apps as well. So it's something that could be used in many different ways, but it's definitely something you could use to help with a gradual transition. So yeah, there's that as well. There was another question here, I think.
Yeah, thank you. So as I understand, child applications are supposed to be aware if they are child applications.
Mm-hmm.
Called get sub-agent.
Mm-hmm.
Get agent. But what do you think? As long as get agent method supports application AD with parameter, can there be a replacement for calling get sub-agent? For example, there is
Mm-hmm.
one Windows store.
Mm-hmm.
And we call get agent with two times with two different.
Yes, yeah, I see where you're going with this. Yeah, I mean, potentially, rather than calling, we haven't really talked about this yet, but potentially, rather than calling get agent and then awaiting that, and then calling get sub-agent as a method off of that, it's theoretically possible we could provide a get sub-agent function that, with the right params, would kind of do the work for you, get the parent app agent first, and then get the sub-agent off it. That may be, a way of slightly simplifying this. We'd probably want to support the sub-agent method anyway, simply because we might not necessarily want to prescribe how people or where in the flow they acquire the reference to their parent agent. It may be that in some situations they're still setting window.fdc3, maybe they haven't moved that part of it yet, but we could potentially provide both. I don't know if you've got perspective on that.
I like the suggestion. I'd love to have a chat about it at one of the upcoming meetings. Probably my least favourite part of the whole proposal is the name of the function. if I'm perfectly honest, so as Derek said a couple of times, it's very much subject to change. We're providing background on where the conversation got up to before we decided to defer it until we'd got the situation settled down in web browsers generally for the parent level applications. So great suggestion. We'd like to talk more about it when there's when we're next in I think it's the FDC3 for web browsers and bridging discussion group that's mainly working on the proposal. Mm-hmm. It will then go on to the standards working group when it's considered ready by that group for consideration more widely and adoption ideally.
And I'd also add actually that if you want to talk about any of this today, we actually will have an FDC3 project booth. Didn't mention this earlier, at 120 downstairs. So anyone who wants to talk any more about this, we can chat this afternoon. Either Kris or I will be there during the afternoon.
I'm sure we can entice some of our other presenters to put in an appearance as well if you've got questions for them. Well, I think most of them have got a stand somewhere here. So,
any other questions from anyone before we wrap up?
In that case, thank you.
There was one from Giles.
Late entry.
In your slides, you illustrated this as applications within a window. So you have a block, which is an application within the same DOM.
Yeah.
Our use case for this is more along the lines of we have one, name's kind of hard here, but we have one application in a DOM, but we want to communicate between different parts of that. So, for example, you have a switch to specify the theme.
Yeah, got it.
So you toggle the switch and then you communicate that to other components within the same DOM. So I would not call the switch an application. application.
Mm.
We want to be able to communicate between different components.
I see.
So this seems like it's more focused between different applications communicating rather than components.
Well, this is interesting because it's the whole thing about what defines an application. When is it an app? When is it a component? When is it a widget? And we use these terms sometimes interchangeably and sometimes we mean distinct things. I mean, it's fair to say that to do this, ultimately it needs an app ID. Whether we call that thing an app or not, that's kind of what it comes down to. So theoretically, you could have, I say theoretically, you could have several dozen different things within one application, which are kind of, let's say, subunits of that application, which might be components. And you could use this for that. It would probably be more useful if it's really between distinct pieces of functionality that are more fully featured components rather than, you know, really small things. To a certain extent, it would be up to the consumer and hopefully wouldn't shoot themselves in the foot with it. That said, you know, you could do crazy things today with FDC3 with really small applications. They'd all be in iframes, but you could do those sorts of things. So, yeah, again, we're just to chat with you further on this.
Yeah. And after all, there are two hard things in computer science: cache invalidation and naming stuff. And that's, I think, the root of your question. We need to get the language sorted out. And as one of the FDC3 maintainers, you can argue with our editor here as well over what the correct terminology would be. I know I, for one, have gone through several rounds of renaming things I work with every day. And you know, getting the language right is always one of the key things, because people need to recognize it. And what you've just done is, like, I don't recognize this exactly mapping to my use case. So that is definitely something we'll have to work on to explain it, as well as finding a sexier name than get subagent.
Yeah, we don't have to call them child apps either, right? This is what the proposal is currently calling them, but it may be that we can get some consensus on a broader term that maybe is understandable for these different range of use cases.
Yeah, I guess my question's kind of thinking slightly more about app directory records and whether your one toggle box would appear in.
Yeah, I mean, to me it feels a little bit odd if you start having single components, there's just a toggle box appearing in your app directory. And this is why there is this open question around, should child apps be in the app directory or should they be managed by the parent app? And to some extent, this relates to the ownership of those child apps. Do they belong only to that one parent, or is this an app that maybe has the right to exist under another parent as well? If it did, you're going to duplicate the management of that if you don't have them in the app directory. But yeah, all good things that we should to talk about, I think, definitely. Thank you. I think with that, we're probably done.
Thank you, everyone.
Thank you.